liquids. The graph here, up to here in 2010, is for all liquids. The shaded bit just on the top here is for natural gas liquids. That's the condensable parts of natural gas. This bit up here, this top bit, this dotted bit, is for gas. And it's a stacked graph, so it's a bit hard to see how it unfolds, but if you unfold it, Colin predicts that natural gas will peak around about 2020. Okay, so we've had peak oil already, we're going to have peak gas in 2020. So that's a problem, but we've got one fossil fuel left, and that's coal. Everyone says we've got lots of coal. Even the environment, well, in fact, one of the main worries of the environmentalists and climate change is that we've got too much coal. Everyone says we've got lots of coal. If you look up the standard statistics, it says we've got about 850 billion tonnes of coal. But if you do the same sort of analysis with coal as people have done with oil, then you get this sort of graph. This is a graph done by a German group called Energy Watch, and they find that peak coal is likely to occur in 2025. Hey, most of the students here are not going to be close to middle age by that time. A paper came out just at the end of last year, published in Energy Policy, which was another graph which showed, did a peak oil analysis on coal, and it showed that peak coal could be as early as 2011. 2011? That's pretty soon. Oh, it's here. I don't find that terribly realistic, because the sorts of geologists suggest that coal is going to have a fairly flat plateau. But just a couple of weeks ago, a more realistic study came out by a Chinese university staff in the US, and he did a separate analysis for both China and the rest of the world. The reason being is that China completely dominates the coal industry at the moment. Last year, China used pretty much as much coal as the whole rest of the world. Okay? By next year, they'll be using more coal than the whole rest of the world is using. So the analysis here, I put the graphs on the same scale so that this is the rest of the world coal use, and it comes up to around about 4 trillion tonnes a year, and China at the moment is about 3.3 billion tonnes a year, and he suggests that China can go up to nearly 5 trillion tonnes a year, nearly doubling but not quite. But the important point is that the peak occurs at the same point for the rest of the world and for China at around about 2027. Okay, 2027 is only 16 years away. At the moment, China is using coal like it's very plentiful. These are the graphs for the US, India, Australia. They're all going up modestly. China, as of about 2004, started shooting up at around about 8% per annum. 8% per annum is a doubling time of under 7 years. So, around about 7 years. So that means in 7 years' time, China will be using double as much coal as it is now. That is clearly unsustainable. Not only is it unsustainable, it's going to cause enormous problems in terms of climate change. The Earth is warming, as most of you already know, and the main culprit is carbon dioxide. Those of you who saw Jim Hansen here a month or so ago, hopefully you've by now read his book, Storms Are My Grandchildren. The current concentration of carbon dioxide in the atmosphere, I looked it up, as of June of this year, it's 393.7 parts per million. Very close now to 400 parts per million. This is of CO2. Now the safe levels are debated. The IPCC says that the safe level is 450 parts per million of CO2 equivalent. And that little E there means it includes all the other greenhouse gases, such as the nitrous oxides and methanes, etc. If you convert the IPCC number just to CO2, it's around about 400. Okay? Jim Hansen, as you all know, suggests that the safe level is 350. In fact, he's not even sure that that's not too high. So we've got a problem. At the moment, we've got nearly 400 parts per million in the atmosphere, and the safe level is 350. According to Jim, the safe level is only possible, we can only reach 350 parts per million, if we don't use any coal after 2030. So all coal emissions need to be halted in 19 years. Just go back to the previous slides where I showed you how fast China is increasing its coal consumption. That, of course, means no lignites for New Zealand. No unconventional fossil fuels can be used. No tar sands, oil shale or methane hydrates. And only conventional oil used. So not the unconventional oils such as polar region oil, deep ocean oil, pristine lands, and no deep ocean oil off New Zealand. This is taken straight out of Jim Hansen's slide, except for the bit referring to New Zealand. This is his graph, which I always refer to when I'm talking about climate change, because it shows just how difficult, it's going to be gloomy, this is really gloomy, how gloomy things are. The red curve here is with the oil industry information and reserve growth. Okay? The top blue line here is the minimum use of oil, so the lower estimates of oil. And you can see what happens. This is with no coal use by 2030. So the world's completely cut out coal use by 2030, and it's using the minimum amount of oil. You see that by 2150, we're only down to about 375 parts per million, way above the safe limit. Okay, so the most optimistic case, when we shut down all the power stations, use the minimum amount of oil, then we can only get down to 375 parts per million. To get lower than that, we've actually got to suck carbon dioxide out of the atmosphere. We've got to plant trees. We've got to put in biocarbon. We've got to force it down, all this blue stuff. And if we do all that, we might get down to 350 parts per million by the end of this century. 90 odd years away. If we really want to get down quickly by 2050, we have to stop using all fossil fuels, all oil and gas, and use biofuels instead. Okay? If that's not depressing, I don't know what isn't. That is really, really difficult. And as I said, when you saw before the rate at which China's increasing its coal consumption, that's going to be very difficult to get to. And you know, of course, if you've heard Jim Hansen, what will happen if we don't? If we don't, temperature of the Earth will go above 2 degrees. And once you get above 2 degrees, then you get into this feedback zone whereby you can't stop things getting worse. Okay? The polar ice caps melt, the tundra starts emitting methane, the Amazon starts burning and producing more carbon dioxide, and you can't stop it. And we know this has happened. This has happened in the past. Jim Hansen gives cases in our geological history where the Earth's temperature went up 11 degrees due to tipping points and climate change which can't be controlled. And the really sort of scary thing in terms of climate change is once we get past this tipping point, what do? Party, because there's no way of stopping it. You're then not talking about mitigation anymore, you're talking about adaptation, how we adapt to the climate change problem. You've all seen the current effects. They're in the newspapers all the time. There were fires in Russia a few years ago, a year or so ago, the floods in Australia, in Pakistan, in China, the tornadoes, twisters and hurricanes, even in New Zealand, the famines in East Africa due to droughts and various droughts. Australia's been in drought on and off. The only time Australia's not in drought is when it's flooding. Okay, so that's climate change. So that's sort of pretty scary. So let's get back to energy. What about nuclear energy? I haven't said anything about that. Presently, it's about 6% of the world's energy supply, which comes from around about 450 nuclear reactors. Maybe I don't need to go on too much more about nuclear. I'll answer questions on it if you like, but it's clearly a very insecure energy supply, mostly because the waste problem hasn't been solved. Okay, so that brings us to renewable, the one ray of hope, one thing that might cheer me up. What about renewables? This is an interview I made earlier this year, and the point I made was it makes sense to put in place renewable alternatives as quickly as possible. In fact, this comes from my very first talk when I talked about peak oil. If you want to transfer from peak oil to other sources such as renewables, you have to do it when the going's good, when you've got money, when you've got energy resources to make the transition. Because wind turbines, solar panels, all the infrastructure which is needed to build a transition society can only be done when you've got plenty of money and an excess of energy. When you're going down the Hubbard slope, when you're decreasing your oil supply, decreasing your coal supply and decreasing your gas supply, society is going to hurt. Okay? They're not going to be able to give up even more energy to make all these devices. Unfortunately, the magazine which printed this was that font of academia, Mind Food. Up for a very short while, I was up there with Reese Witherspoon, but it didn't last very long. Okay, so that's the energy situation. I also was talking about the economy. So let's have a look at what money is. Is oil money? Remember the old, money is a token for exchange, which means that when you exchange money, you have to be able to do something with it. Build a house or buy a car or buy a computer or laptop. Okay, but most people want tangible items. A few people want services such as Facebook. We discussed this the other day, and if we convince the whole world to aspire to virtual houses and virtual cars, then we'd probably be set. But it's unlikely to happen. It's fairly hard to impress your girlfriend with a virtual diamond ring. Okay, so let's look at the history of energy and money. This is a history of oil and world GDP. In the early part of last century, world GDP was rising by a fairly hefty 4.65% per annum, and oil use was increasing by an even larger amount, about 7.35% per annum. Then we had the oil crises, and that sort of shook people up, and they started using energy more efficiently. And after the oil crises, things changed around such that oil only increased by about 1.6% per annum, but GDP increased by about twice that, by about 3.2% per annum. And they follow each other very closely. There's a bit of mathematics involved here, but because the percentages are double, so GDP is increasing double the amount of oil, when you plot the graphs of one squared against the other, you find that they follow each other very closely. And you find, in fact, that oil and GDP follow each other very, very closely, right up to when I started giving my first talk on peak oil, which is 2005. And since then, world GDP has actually been increasing, but oil supply has stayed very static. So the blue one here is oil supply, it's static, and except for 2008, when world GDP did go down between 2008 and 2009, world GDP has been increasing. So, what's going on here? I must be wrong. Does this mean there's a decoupling? Does it mean we can increase our wealth but not use as much energy? But there are two factors which lead me to believe that this is probably not right. The two factors are world debt and coal consumption. If you look at world debt over the last 5 or 6 years, you find that world debt has been increasing at a larger rate. All governments of the world, not only the US, but New Zealand, Greece, of course. Greece's debt now is at 179% of GDP. The US debt is very close to 100% of GDP.